Okay, how's it going, guys? We're going to do the graphing trigonometric functions test review. This is what I gave you in class, and now we're going to go ahead and just go over the whole thing as quickly as possible. We're going to go ahead and start with number one with this graph. This is a sine graph, sinusoid, okay? So regular plain Jane sine graph. So this is your vertical shift, -2. Okay, so we're going to put the center line at -2. That's what that means. Usually it's on the x-axis, but we're moving it down by 2. And we're just going to put a little center line like this, okay? Now we look at the coefficient of sine, that is 1. All right, so that tells you from the middle line right here, we're going to go up 1 and down 1 from the middle, right? So this is telling you how far up and down from the middle to go. So we're going to go up 1, and we're going to go down 1. Okay. All right, so we're going to go ahead and have to graph this here. But what I'm thinking, though, is I need to know what the period of sine is. So I say, okay, the period of sine is 2 pi over the absolute value of b. B being this number here in front of x, which is a half. So the period is 2 pi over a half, which is the same thing as 4 pi. As you can see, though, I've already marked that right here, 4 pi. It's already been quartered for you nicely. So, and what we're going to do basically now is basically figure out where is sine at the top of its graph, okay? So we're going to have to set this equal to something. And what that target is, though, is going to be this angle right here, which is pi over 2. And the reason that is because this pointer here at the top is 0, 1. And this is the sine value, this 1 right here. So this angle being pi over 2, I can say definitively that the sine of pi over 2 is actually equal to 1. So I want this whole thing to be the same thing as 1. So this right here must equal, of course, what? Pi over 2. That's the idea. So let's do that. Let's set it equal to pi over 2 and solve it. So I say, okay, 1/2 x plus pi is equal to pi over 2. I'll subtract pi from both sides. So 1/2 x is equal to negative pi over 2. Multiply both sides of this equation by 2. So x is equal to negative pi. And that's where the top of your graph will be, okay? And let's start drawing it here. So at negative pi, which is right here, this is negative pi, we're going to be at the top of our graph. So it's going to be a point at the top of the graph. And because we know the period is 4 pi, I can move 4 pi over and have a top again. So we can count this, 1, 2, 3, 4. 4 pi is 4 spaces. So we're going to count 1, 2, 3, 4. So I'm at the top of the graph right here. Let's go this way, 1, 2, 3, 4. Top of the graph right here. 1, 2, 3. I'm not quite there. Let's see if I can go any further this way. 1, 2, 3, 4. Yep. Top of the graph right here. Right in the middle between two maximum points is right dead center is a minimum point. So right in between the two top points we'll have a bottom point. And in between the bottom and the top we're going to have an intermediate point on the midline, which is right here. And of course right here on the y-axis. And right here there's a bottom point in between these two top points. So we're just kind of following this pattern we see, okay? And we're just going to keep it going for a little while longer. And then we're going to graph. So this is kind of what this graph is going to do. And it's going to hit all these intermediate points. So we're going to do this. Kind of go up and down with it. Oops, totally missed that point. Eeks. It's going something like that. So this one right here really should have gone, you know, through there like that. So that's kind of what this sine graph looks like. That's the graph I'm expecting you to have for that question. So I think there's 13 questions on this. We're already done with one, so we can kind of get this done in a relatively short period of time. I know you guys are not going to want to stay up too late to watch this. So let's go ahead and graph secant. So the first thing I'm going to do is I'm actually going to graph the negative cosine of 2x plus pi over 2 minus 1. Cosine is the reciprocal of secant, so I can graph secant easily if I can graph its reciprocal cosine. So I'm going to graph this first, and then secant will be kind of laid out for me. So I have -1, that's my shift, vertical shift. Okay, and the cosine here has a -1 in front of it, so it means go up 1 and down 1 from that center. So I'm going to go up 1 from the line I just wrote, and go down 1. So Cosine graph will be in between here and here. Okay, so I need to figure out then, where does cosine have a maximum point? Well, if I set this equal to 0, that's when I'll find it. So I'm going to say 2x plus pi over 2 equals 0. That's finding what is typically a maximum point for cosine. So solving this equation is going to say 2x is equal to negative pi over 2. Divide both sides by 2, so x is going to equal negative pi over 4. All right, so that's basically a maximum point for me, except not in this case, because you need to be wary of the fact that this is a negative, which means this graph is upside down. So negative pi over 4, which is usually a top point, will now be a bottom point for this particular graph, just because of this negative 1 in front. The period for this cosine is 2 pi over 2, which is just pi. As you can see, it's 1, 2, 3, 4 spaces. I've already quartered it for you. So we're going to move over 4 spaces from here. 1, 2, 3, 4, and that's a bottom point. 1, 2, 3, 4, and a bottom point. Go this way, 1, 2, 3, 4, bottom point, and so on. In between the two bottom points, right in the middle, is the top point, and a top point here, and a symmetrical right split these is going to be a top point. So I have an intermediate point in between these, an intermediate point in between these, and so forth. And that's kind of what this graph is going to look like. So something like that. And then we're going to connect the dots. It's harder to draw on here than you think. Okay, that's actually the graph for cosine, but I actually wanted this graph, secant, so I haven't really drawn that yet, so we're not really done at all. But I know that secant has asymptotes wherever cosine will hit this middle line right here. So this point, these are the locations of asymptotes for the secant graph. Okay, we've discussed this several times in class. Secant graph right here. Asymptote, asymptote, here, and here. Okay, so the final step for graphing is to put points on the top and then fan them out toward the asymptotes like this on each peak of this graph, this cosine graph. Okay, so it's going to look like this and something like this. Okay, down this way, down this way, down this way, down this way, and so forth. So this purple stuff is actually your cosecant graph right here. So this is kind of what we're looking for when you graph these. Number 3, very straightforward problem. This is sine over cosine. The stuff in the parentheses is the same. So I can say sine or cosine, of course, is very well known. It's tangent. So this is basically the tangent of x plus pi over 2. And that's all I'm really graphing. This stuff you can really ignore. I'm only caring about this right now. So we're going to graph tangent of x plus 2. And let's change up this pen a little bit. So I'm going to say, okay, tangent is defined by 3 points in between every asymptote that it has. So the midpoint is going to be on the x-axis because there's no vertical shift in this graph. We can see that the coefficient of tangent is 1, so we're going to go 1 up from there. And 1 down. Okay. Now if you follow along here, I'm going to go ahead and let's change this up a little bit. I'm going to do 2 things. I'm going to find an asymptote and I'm going to find the period. Once I have both of those, I know where all the asymptotes will be. Okay, so I'll find the first asymptote first. This is what I'm going to use. And for tangent, we know that there's an asymptote at pi over 2 for the parent function tangent of x. So what I'm going to do then is set x plus pi over 2 equal to pi over 2. This is what you always do for tangent. You set the inside of this equal to pi over 2 to find one of the asymptotes. If I subtract pi over 2 from both sides, x is simply going to be 0. So it tells me right away that on the y-axis, that's actually a vertical asymptote. Now, I don't know where the other asymptotes are, so I have to find the period of the graph. And the period for tangent is pi over the absolute value of b. And b is this number in front of x, which is 1. So it's basically pi over 1, which is the same thing as pi. So if I go over a distance of pi, which is 1, 2, 3, 4 spaces, I have another asymptote. That's what it means. So I keep doing this, go over 4 spaces, another asymptote. And I go over 4 spaces this way, and another asymptote. And 4 spaces this way, 1, 2, 3, 4, another asymptote. Very good. All right. Now, all I got to do is put the points down and graph. So, as I can see here, this is a coefficient of 1, so there's no negative trickery going on. It's just in between the asymptotes, we're going to hit this middle line, which is dead center right here. Tangent, what we'll do is in between this asymptote and the midpoint will be on a low side right here. And in between this point and this asymptote, we're going to be at the top. And this pattern is going to repeat over and over again for tangent, typically, is what it looks like. So I'm going to keep doing this, and we're going to connect all these. So it's going to go like this toward the asymptotes. Circle through these points toward the asymptotes. Cycle through these points toward the asymptotes. Here we go. And we got that. So this is the graph for tangent of x plus pi over 2. So that's the answer for number 3. Let's jump over to number 4. All right. And let's keep going with this. This is a really simple graph. The only thing tricky about it is we put a pi here on this b value. So that's the only thing that's going to be kind of weird. So we're going to say the center line is at -1. I can tell that the coefficient of tangent's 1, so that means I'm going to go up 1 from the center and down 1 from the center. Kind of like this. All right. So what I'm going to do now is actually figure out the period and the location of one of the asymptotes. So the period, again, for tangent is pi over the absolute value of b. The absolute value of b here is those pi over 2. So I'm going to say this is pi divided by pi over 2. Now, what you're really doing is multiplying this by the reciprocal of this bottom part, which is really 2 over pi. That's what you're multiplying by. And when you multiply this times this, these pi's cancel. So this is really just 2. That's the period of the graph right here. Okay, that's the period. It's 2. Now, the only thing I have to do now is find the asymptote, and for tangent, you always set the parentheses equal to pi over 2 to find a location of one asymptote. So this is equal to pi over 2. If I divide both sides by pi over 2, which is what I'm doing, these will cancel and give me 1, and these will cancel and give me 1. So I got 1 times x equals 1. In other words, x equals 1. That's the location of your first asymptote at 1. So we have an asymptote at 1 right there. Okay, the period is 2, so we're going to go over 1, 2. Okay, sorry, this is 1. A space of 1 is what? From 1 to 2, that's 1. So we go 1, 2. So we're at 3 now. It's 2 more than 1. We go 2 this way, 1, 2. 2 this way, 1, 2. And we have the asymptotes. Now, this graph is done the same way of the previous graph we just did on the previous question. So we're just going to put a point in the middle on the center line, and then put in the middle right here, point down, point up, and go this way. And that's your tangent graph for this function right here. Very, very simple. Easy stuff, really. And we just kind of do 2 or 3 of these. There's an infinite number of these, but they kind of look like that. So that'll be number 4. Let's jump to number 5. Try to get this done relatively soon. -1. That's the shift. -1. Okay, and there's in front of the tangent we see another -1 right there. So that means go up 1 and down 1. All right, very well. Okay, so again, find the period for tangent. It's pi over the absolute value of b. b is in this case 1/4, so it's pi over 1/4, which becomes 4 pi. As you can see, I've already marked that off and quartered it for you. We're going to set this equal to pi over 2 again for tangent, so we say 1/4 x plus pi should equal pi over 2. That means 1/4 x, when I subtract pi from both sides, will be negative pi over 2. And then multiply both sides by 4. So x should equal negative 2 pi when you do that. So that's what your first asymptote will be. So negative 2 pi, that is an asymptote. Since the period is 4 pi, we have to count 4 spaces. So we're going to say 1, 2, 3, 4. And there's another asymptote there. And then we say 1, 2, 3, 4. Another asymptote there. And this way, 1, 2, 3, 4, asymptote. And this graph is a negative in front of the tangent, so instead of going up like this, it's going to go the other way. It's going to be upside down and go that way instead. So make sure you keep that in mind, because that will throw you off. We're going to have a point in the middle, but instead of going from here to here, we're going to go from the top this way and this way. So it's going to look like a cotangent graph, in other words. So it's going to kind of look like this. And we got a point here, and a point here, and a point here, and we go this way with it. Like that. We got a point here, we got a point here, we got a point here, and it goes this way with it, like that, and so forth. So kind of get the idea of what's happening here. So we're going to jump down to number 6. Just keep going on through. Okay, so number 6 now. We're going to go ahead and put the midline down at -1. There's a vertical shift there from the x-axis. This 2 right here is telling me to go 2 up and 2 down from there. So I'm going to go up 1, 2 at +1. I'm going to go 2 down to -3. So it's going to look like this. Very straightforward. Okay, cotangent. We're going to set cotangent. Well, first find the period for cotangent. So it's going to be pi over the absolute value of b, just like tangent. And b is 2. So we're going to say this is pi over 2. As you can see, I've already marked this off. I think your grid might be a little different than mine, but this is pi over 2. Just keep that in mind when you're drawing. Pi over 2 is where the space for here. So I think your space is actually 2 spaces for pi over 2. Mine is 4. But don't let it freak you out too much. Just make sure that your asymptote's in the right spot. So the first asymptote we're going to set this equal to 2x minus pi over 2. We'll set it equal to 0. So for tangent, we set this equal to pi over 2, but for cotangent, we'll set it equal to 0. That's how you find an asymptote. So 2x is equal to pi over 2 now, which means x will equal pi over 4. That is the location of your first asymptote. So find pi over 4 on your graph. Make sure you see it, and that will be the location of your asymptote. Okay. Now the distance here is pi over 2 for the period, which for me is 1, 2, 3, 4 spaces. That's pi over 2 because I can count them 1, 2, 3, 4. But I believe on your paper it'll only be 2. So only go 2 spaces on your paper. Mine it's 4. So I'm going to say 1, 2, 3, 4. So make sure you have an asymptote at -3 pi over 4. And here go 1, 2, 3, 4. So positive 3 pi over 4. You have another asymptote. Okay. So the way your graph will go is that you'll have a point again in the middle, right at square in the middle at pi over 2. And at 0. Okay. Alright, so what I'm going to do now is I'm going to put a point. This is a cotangent graph, so it's going to go kind of this way. So we're going to go right in the middle up and right in the middle down. Right in the middle up and right in the middle down. Your graph will look narrower than mine because you only have 2 spaces to work with instead of my 4. So just keep that in mind. It won't look exactly the same, but very close. So we got a point here, point up, point down, and that way. We did do this in class, so shouldn't be a mystery. And we'll go on to number 7. All right, let's just go on through this. This is a basic sine graph, so -1 is your shift. -1, that's your center line. 2 is the coefficient of sine, so we go 2 up from the middle line. And 2 down, which is at -3. So your graph will go up and down between the top and bottom here. Okay, the period for sine, of course, is 2 pi over the absolute value of b, which is 2 pi over this number, which is 2. So it's 2 pi over 2, and that's going to cross that out, so it's going to be pi. As you can see, I've already marked that for you, pi. It's quartered. So to find a maximum for sine, we'll set it equal, this stuff right here, we'll set it equal to pi over 2. That's what it always is for the maximum for sine graphs. So it's pi over 2. So that means 2x will equal negative pi over 2 because I'm subtracting pi from both sides. And then I divide both sides by 2. And it's going to give me negative pi over 4. So negative pi over 4 is a maximum point. And because the period is pi, and pi is 1, 2, 3, 4 spaces, I'm going to count 1, 2, 3, 4 spaces, and I'll be at the top again. So I say 1, 2, 3, 4, top. Okay, 1, 2, 3, 4, top. In between the 2 top points is a bottom point way down here, and down here, and down here. This distance from point to point, for top and bottom, is the period of pi. So I say down here. And in between the top and the bottom, there's a middle point, and that's going to be the midline right there, right there, right there, right there, 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 and there. So, lo and behold, we have a graph that does this. Ooh, not a good looking one either. Yeah, let's undo that. Let's see if I can undo that. Yeah, let's try that again. Terrible drawing, gotta say. Hard to do on this with this pen. So that'll have to work. Shouldn't look so triangular, but that's the graph for sine. Okay, should be a little more wavy. Okay, so that's that. I'm going to go ahead and graph number 8. All right, so let me get rid of this graph I just made. But anyway, to take a look at this, this is the answer for number 7, but I'm going to erase it so I can look at number 8 more carefully. All right, so I'm just going to kind of grab an eraser here and kind of get rid of that. So number 8, let's do number 8. Alrighty. So we have a shift at 2, so that's going to be the center of my graph. This is a cosecant graph, so I'm going to pretend this is actually a sine instead, because sine is the reciprocal of cosecant. So I'm going to graph this, and then this will be easy to graph. So I'm going to pretend here that this is the graph I'm going to make, and there's a -1 in front of sine. So that means from the center here, I'm going to go up 1 and down 1. Oops. Okay. What else am I going to do? Drawing stuff here. This is what I'm going to do. I'm going to go ahead and put a figure out the period for the sine graph, which is 2 pi over a half divided by this number right here. This is actually going to be 4 pi, and as you can see, I've marked it off for you. 4 pi, 3 pi, 2 pi, pi. This will be set equal to pi over 2, just like the previous graph. And when I do this, 1/2 x will equal, I'm going to add 2 pi to both sides, so I'm going to say this is pi over 2 plus 2 pi. Keep in mind 2 pi is the same thing as 4 pi divided by 2. 4 divided by 2 is the same thing as 2. So it's kind of like doing this, like adding these guys together. And then we say 1 plus 4 is 5 pi over 2. So 1/2 x is equal to 5 pi over 2. Multiply both sides by 2, cross those out, so x is equal to 5 pi. Ordinarily, I would say this is a maximum point because I set it equal to pi over 2, but keep in mind this is a negative number, so 5 pi right here is not a maximum point, it's actually a minimum point right there. We follow the period 4 pi, so we go 4 spaces, 1, 2, 3, 4, so I got a point. And I say 1, 2, 3, 4, and I got a point. And I say 1, 2, 3, 4, and I got a point. In between the two bottom points, right dead center at 3 pi will be at the top. And here at negative pi, I should say negative pi, and right here. So it's kind of looking like that, I'm thinking here. So we're going to have the intermediate points, of course, which are not very well drawn, but that's all right. And boom, 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 boom. And then we draw. Wow, not so good. Terrible, terrible. Yeah, it's a very ugly graph, but again, we're not trying to graph that anyway. We're trying to graph what? Cosecant. So where it hits the middle, which should be this point, there should be a what? An asymptote right there. And right there as well. And right where it hits the middle right there. And right here. And another asymptote here. And one right there. And right there. Wherever it hits the middle line right here, you can see that's where I want to go with the asymptotes. So the cosecant graph, just to sketch it, it'll look like this. You put points on the top, and you'll fan it out toward the asymptotes. Points on the top, they go up toward the asymptotes. Up toward the end. They go up forever, of course, but you won't see that. You won't be able to draw that far. And something like that. We'll just keep going on this pattern, top and bottom. Blah, 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 right? Okay, so that's what your graph for cosecant will look like, you know, pretty rough right there, but there it is. Number 9, secant of 2x minus pi over 2 minus 1. Okay, secant, the reciprocal of secant is cosine. So this is 2x minus pi over 2 minus 1. That's what I'm going to actually graph first. Okay, so the shift is -1. That's where the shift is going to be. Vertical shift, that's the new center line. The coefficient of cosine is 1, so I'm going to go 1 up and 1 down. 1 up, 1 down. Okay. Cosine is a period of 2 pi over b, absolute value of b. So this is 2 pi over this number, which is 2. So pi will be the period, and I already marked it off, pi. It's quartered already for you. So we're going to set this parentheses for cosine. Always set it equal to 0 if you're looking for a maximum point. So 2x minus pi over 2 equals 0 if I'm looking for the top of the graph. So that means 2x is equal to pi over 2, and that x itself is actually equal to pi over 4, because I'm going to divide both sides by 2. So that's the top of my graph. I'm going to go ahead and use a pin on that. At pi over 4, I'm at the top. The period is pi, which is 4 spaces, so I go 1, 2, 3, 4. I'm at the top again. 1, 2, 3, 4, top. 1, 2, 3, 4, top. And in between the two tops is the bottom points, dead center in between them. And then in between them are the intermediate points that we're going to put in the midline. Very straightforward, very symmetrical, and something like this. So we go all the way through with this not so well drawn graph of mine. And that's the cosine graph. Now keep in mind, I did not want a cosine graph, I wanted the secant graph. So all I have to do is find the midline points and draw the asymptotes down. And then I'll get something that looks a little more like I want it to look like. This is very poorly drawn, but I'm in a hurry and my pen is not perfect. So where's my coordination? So we're going to say, okay, at the top, we're going to fan it upward, fan this upward, fan this upward. On the bottom, we're going to fan this down. We're going really fast here. Fan this down, fan this up, fan this down. See, it shouldn't look like a V. It should look like a curve, a nice smooth curve there. And like that. So the red graph is actually your secant graph, and that's kind of what I'm looking for there. Okay, so we're going to move on to number 10. So we're done with the graphing bit, so now we're just going to figure out these blanks here. We're almost done. So, okay, if I think of a sine equation, like a sine of bx minus c, this is a standard one that we use. If I have an equation written like this, then the amplitude will be the absolute value of a. So a is the number being multiplied by sine, and in this case that's 1. 1 times sine right here. So the amplitude is 1. Okay? Remember, it's always a positive number because you're taking the absolute value of that number. Okay? The period for sine will be 2 pi over the absolute value of b. And remember, b is this number in front of x, so in this case it's a half. So if I say 2 pi over a half, 2 pi over a half, that's actually the same thing as 4 pi. So that's actually the value of my period, 4 pi. Your phase shift, if your graph equation is written like this, is given as this phase shift. See, this is different. The phase shift will be c over b. That's your phase shift right there. So it's this number divided by this number. One difference, though, I should notice is that this is a negative sign and this is a positive sign. So this is only true if this is negative. Okay, if it's not negative and it's positive, then this value should be considered negative for c. So in this case, I have negative pi. That's my c value. Okay, you change the c to the opposite sign. So if this is negative, c is positive. If this is positive, c will be negative. And you divide by the b value, which is a half. So this is going to give me negative 2 pi, and that's actually my phase shift right here. Your vertical shift is just the value d right there. Just the value d for the vertical shift. It's the standalone value, which is negative 2. And that's the answer for that, all that stuff. Okay, amplitude. We need to talk about that really quick before I continue on. If I graph a sine wave, typically it looks something like this. This distance here from the middle to the top is called your amplitude. Okay, right here. Secant graphs don't do that. Okay, secant graphs will go up forever, and they will go down this way forever with an asymptote right here. They don't have an amplitude. They don't have a top and a middle point necessarily. So for anything that's not a sine graph or a cosine graph, we're going to put not applicable for the amplitude, because I really don't want you to think there's something going on there. So that secant graph has no amplitude because we can't really measure the top of this graph because it goes up forever. Okay. The period, though, anything that's not sine and cosine, the period is pi over the absolute value of b. So b is 2, so this is going to be pi over 2, and that's the period that we get. Okay. The phase shift, again, if this is positive, this should be considered negative, so it's negative pi over 2 divided by this number 2. It's the same thing as this one right here. So in this case, though, this is going to be negative. Oh, my pen just died. No, negative pi over 4 when I do that. So that's your phase shift, negative pi over 4. Your vertical shift, again, is the standalone value of negative 2, and that's your vertical shift. So we're done with number 11. Let's continue to number 12. Okay, cosecant, again, does the same thing sine does. It goes up forever and down forever across asymptotes here. So there is no amplitude to measure. It's not really valid for this problem. The period is going to be pi over b because it's not a sine or a cosine graph. So pi over 4, in other words. So that's your period. That's pretty straightforward. Your phase shift, again, it's going to be, if this is a positive right here, this should be considered a negative number for the phase shift. So it's negative pi over 4 divided by 4. This is indicating that when you see this plus sign and your phase shift will be negative, you're going which direction? It's shifting to the left. Okay, so if I divide this, it's going to give me negative pi over 16, and that's your answer for the phase shift. So whenever you see a plus sign, it means your phase shift is actually negative. If you see a negative sign here, your phase shift will be positive. And this means it's going pi over 16 to the left. That's what it means. Your vertical shift is a standalone value of 3, and that's that. So nearly done. Last question. Okay, last graph. So again, this is a secant graph, so it's going to go up kind of forever and down forever this way. Oops, that's not really true. It's going to go up forever, and then you're going to have some stuff in here, and it's going to go down forever. And there's an asymptote, of course. So the point of this, though, is there's no amplitude to measure, so this is not applicable right there. The period for a secant graph is pi over the absolute value of b. And this is pi over this value right here, which is 1 over 8. So when I divide this, this is going to give me 8 pi, and that's the period. Very straightforward. The phase shift is going to be, because this is a plus sign, it's going to be basically, it's going to be c over b, but we're going to think of this as being a negative value. Okay, that's what happens when this is positive. So we're going to say this is like a negative pi over 2 divided by 1 over 8. So when you divide by a fraction, you multiply by its reciprocal, so 8 over 1. So we got 8 times pi, which is negative 8 pi over 2, which is actually negative 4 pi. And that's the actual phase shift right here. And the vertical shift is a standalone value, negative 1. I know that was kind of fast, but again, I'm trying to get this posted so you guys can actually watch it before you have to go to sleep and all that. So I appreciate you watching. I hope you learned something, and I hope you're paying attention in class. Good luck tomorrow, and I will see you then. All right, bye-bye.